Today we are going to explore one of the most revolutionary technologies of the modern era, unmanned aerial vehicle, commonly known as UAV or drones. We are going to see its innovation, application, and future trends. This project is done by a group of members, namely Sachin Kumar Yadav, Saurav Kumar, Prantik Majil, Vaibhav Vishal. Now we are going to see what things we are going to cover in this project. Definition of UAV, application of UAV, UAV path planning, its objective and its constraint, different approaches for path planning. Inside different approaches, we are going to see heuristic approach. Heuristic approach, we are going to explore A star based algorithm, BLP based algorithm, and greedy based algorithm. Then analysis and conclusion. Now we are going to see what is UAV. Unmanned aerial vehicles are flying mobile robots that operate without an onboard human pilot. They can perform various tasks autonomously or be remotely controlled, making them highly versatile and different applications. UAV can navigate dynamic environment using sensor, GPS, and AI-based control systems. Their application ranges from military surveillances to commercial delivery services, showcasing their adaptability in both structured and unstructured environments. Now we are going to see the application of UAV and their role in solving real-world problem. First application we are going to see is security and surveillances. How UAV enhance safety and crime prevention. By UAV is helpful in border surveillances, crowd control, and event security. Second one we are going to see in the sector of agriculture, how UAV improve crop production and farm management. In this field, UAV helps by crop health monitoring. UAV equipped with multispectral cameras detect early signs of crop stress, disease, and pest mm, infestations. Precision spraying. UAV uses GPS guided system to spray pesticides and fertilizers only where they are required. Third one we are going to see is emergency response and disaster management. Let us see how UAV save lives in crisis situation. In here in emergency response and disaster management, there is a problem such as earthquake, floods, and wildfires often destroy infrastructure, making it difficult for resource rescue team to access affected areas and locate survivors quickly. Uh, we can solve these issues by search and rescue mission, damage assessment, medical supply delivery in isolated or disaster hit areas where roads are blocked. UAV deliver machines, medicines, blood samples, and emergency supplies to hospitals and relief centers. Wildfire and flood monitoring. And fourth one we are going to see is archaeology, how UAV help in discovering and preserving ancient sites. UAV help in aerial site mapping, underground structure detection, 3D construction heritage sites. UAV create digital 3D model of temples, pyramids, and ancient buildings, adding in preservation and virtual tourism, monitoring and conservation. Fifth one we are going to see is meteorology, how UAV improve weather forecasting and climate research. Uh, in traditional weather forecasting, there is some problem uh, uh, like that. There is some problem like that. Weather forecasting relies on ground-based station and satellite. It cannot provide detailed atmospheric data about various altitudes, especially in remote location or extreme weather condition. UAV help by atmospheric data collection, air pollution monitoring, glacier and climate change research. Now we are going to see is what is UAV path planning. UAV path planning is a crucial aspect of autonomous navigation and control, ensuring that an unmanned aerial vehicle follow an optimal and collision-free trajectory to its destination. UAV path planning, objective and concept. UAV path planning ensures safe, efficient, and cost-effective flight by optimizing routes while considering environmental and operational constraints. From path objective and constraints, these topics are covered by our mate Prantik Majil. Okay, thank you.
So in UAV path planning, there is various objectives that we want to fulfill. So what is these objectives? The first objective is that path optimization. Path optimization means that if I have a UAV at point A. I want to go to the point B. Okay. What is the best path to go to the point A to the point B? Okay. Best path means that this path will be less obstacle, less distance, and the flight efficiency will increase. That will be the best path. Okay. And the next objectives we are going time efficiency. What is time efficiency? Efficiency means that uh, the speed IUV calculates the optimal flight path. Like at the real time, an UAV A wants to go to the point B. In real time, it is calculating what is the best path. Okay, so it is crucial for like emergency responses. Like in the emergency responses, there will be a fixed time. In this fixed time, we have to find the path that will lead to point A to the point B. So it should be very time efficient. Okay, and we are going to the next um, objective is collision avoidance. Collision avoidance means that from path A, in path A, there must be various kind of collisions. Like how to avoid all those collisions. Okay, we have various methods to avoid those collisions, like in the sensor in the UAV, and also AI-based navigation and autonomous maneuvering to prevent crashes and ensure safety. And the next objective we are going to that is cost efficiency. What is cost efficiency? Cost efficiency minimize operational expenses including fuel, battery, hardware, and computation cost and optimizing UV performance and affordability. Okay, we have done all those objectives. Then we are going to this. What is the constant? The EAV plug plane, what is the constant that we have to in this mind? First constant is altitude. Altitude means that in what in what altitude is the best for UAV. Like if the altitude is high, then it requires more power to sustain this altitude. If the altitude is low, the low altitude, there is more risk of that we can collide with the obstacles. So maintain balance between high altitude and low altitude. And the next constant is climb descent angles. The climb descent angles determine how UAV transition between altitudes, impacting fuel efficiency and maneuverability, especially for fixed wing drones. Okay. And the next constant we are focusing that energy consumption. Energy consumption depends on factors like flight time, like distance we're traveling from one point to this point. What is the altitude we are here, low altitude or high altitude? And what is the power source we are using? Like power source can be fuel, battery, solar. Okay, these all kind of things affects the EAV endurance. Okay. Then the next constant is obstacle and threats. In the path from point A to point B, the path in this path there can be various obstacles. Those obstacles can be divided in two ways. What is static? Static means like buildings, mountains, trees, and dynamic means that moving objects like flies, birds in the sky. In the sky. Okay, we have to avoid these threats. Also, there is some obstacles like missile attacks. Missile can be attack a drone. Okay, or also have radar detection. We have to avoid this. Okay, and the next constant is UAV access. Like how the UAV moves. There is three axes. Three axes is pitch. Pitch means tilt forward or backward. Roll means sideways tilt. And wire means left and right rotation. Okay. These axes are very crucial for control and stable flight for UAV. And then next constant is velocity. So we have to maintain an optimal velocity. To maintaining the optimal velocity, it affects the fuel efficiency, flight stability, and also we have to maintain the energy conservation. Okay, and also we have to balance the what is the optimal speed. Okay, that is very crucial for our UAV. Now we have done with what is the UAV path planning objectives. Then we are discussed about the constraints. Now we are going to the what is the different approaches for path planning. Okay, there is various approaches in the path planning. These are like here the various approaches we can classify it into five categories. The five categories are classical approaches, heuristic approaches, meta heuristic approaches, machine learning approaches, and hybridized approaches. Now we are focusing on the heuristic approaches. So the heuristic approach will be discussed by Saurabh Kumar next. Thank you.
Hello everyone. Here we are going to see the UAV path planning algorithm using heuristic approach. There are many algorithms. What here we are discuss three main algorithms. A star based algorithm, Y level programming algorithm, and greedy based algorithm. Now come to the first algorithm, a star-based algorithm. This algorithm is hybrid. Oh, hybrid means here it works in two steps. In the first step, using a star method, we find the optimal path. And in the second step, using the virtual force method, we are going to find the virtual force from the uh, object, obstacle, and the goal node. Now come to first step. As in first step, the method works like as we first find the optimal FM at each node, and the optimal FM is given by the formula FM is equal to GM plus HM. Here, FM denotes the estimated path cost start to the node M to goal. GM represents the actual path from the start, and HM is the estimated path cost from M to goal. In the virtual method, we generally find the repulsive force and the attractive force. Here we can, here we are taking a real life scenario. Just see this image here. Uh, Initially, drone are at coordinate 00 and it has to reach the coordinate 55. And in between, there are two types of obstacle. One is tree, that is fixed obstacle, and one is a dynamic obstacle, then like moving car at 4 coordinate. Here we are applying a step one, A star algorithm. Here we are taking the heuristic Euclidean distance from the goal node. As here we can see the initial path found using A star is 00112244, then reach to the goal 55. Here it cannot avoid the dynamic obstacle. To solve this problem, we are going to see the second step. In the second step, we find the virtual force from that obstacle. The here the force is given by the formula as like in Coulomb's law, yeah, gravity force. Gravity force. Here F is equal to K by uh, distance of square of distance between object and obstacle. Here we can calculate the force at 2 coordinate. Attractive force from the target is 0.56 and the repulsive force from the moving vehicle at 4 come minus 1.2, resulting net force is minus 0.7. Since the net force is negative, the drone adjusts its path away from the 4-4. Uh, as after adjusting the path, the actual path is 0011223243 and 55. As it refines the path that is found using the A star that avoid the dynamic vehicle at 4-4. Now come to the final analysis of this algorithm. Here, a step 1 A star uh, find the best static path before the drone start moving and avoid non-fixed obstacle like trees. In the second step, hybrid virtual force enables the real-time adaptation dynamically react to the unexpected obstacle like moving vehicle, ensure a smooth and safe navigation without abrupt turns. Now see this graph. This is graph using A star. What here we can see uh, their path is not as smooth as the dynamic obstacle come. What in case of SVF we can see the path are refined by the virtual force, which helps to avoid collision and give the optimal output. Now come to the second heuristic approach algorithm for UV path planning, VLP algorithm. This algorithm is two-level optimization, objective and constraints. VLP, it is a optimization framework that's divided into the hierarchical levels. We we can say this model consists of decision variables, optimal objectives, and constraint in leader and follower levels. Here, leader objective intend to enhance the convergence and obtain an optimal path. It has higher priority than the follower objectives, which optimizes the local effect and conversely influences the leader. Two decision objective exhibits a hierarchical characteristic. Thank you.
Thank you, Saurav. Hello everyone, I am Vahav Vishal. So moving forward in the video, I am going to discuss about greedy heuristic algorithms, which is third of the type heuristic based algorithms for UAV path planning. So greedy algorithms are like very famous algorithms, as we all know. It basically just like stepwise select the best step or move in hope of getting the like in hope of achieving the optimal solution. So in greedy heuristic algorithm, we are going to discuss three similar algorithms, which are greedy least cost, in short GLC, first detect, first reserve, in short FDFR, and the third one is optimal path planning OPP. So first GLC. In GLC, we basically assign each UAV with a minimal cost. So as we can see in the figure, the dot circle in blue, these are the UAV initials. The red dots are basically the destination or endpoints, and these shows the path that are assigned to UAVs. And we have one decision variable which is AIJN. So it says the ith UAV is assigned to reach jth location or endpoint in altitude n. So this one is reaching, let's say, in altitude 1. Then the third one will fly in altitude, in second altitude, above or below that one. So GLC uses a special concept called space discretization to avoid the collision between UAVs. So in space discretization, we basically take a 3D space and divide into multiple layers of 2D spaces. So in order to avoid collision, we basically assign different 2D layers to different UAVs if they are crossing the path. Similarly, in FDFR. So in FDFR, rather than assigning the path with the minimal cost, we try to like minimize the probability of collision. So as we can see here, in the first one, if UAV 2 and 3 move in same 2D space, then it may collide. So in this algorithm we are avoiding that collision, but this algorithm may not give a optimal solution, or like solution with minimum cost or low cost. So it is higher in energy consumption. Here also we use space discretization concept to avoid the collision in unavoidable situations. Thirdly and last, greedy algorithm, OPP. OPP is nothing but basically hybridization of GLC and FDFR algorithms. We use it to like enhance the energy consumption, so and gives a better optimal UAV path. So in this, as we can see, like first the UAV 4 initial is assigned to 1, but which may not be optimal, because if we assign 3 to 1, then it will become much shorter, and like overall the length overall will decrease. And so this is the better algorithm than both discussed earlier. Lastly, we will analyze the different heuristic approaches that is already discussed previously. So first we have A star based algorithms, heuristic approaches, which are very good to converging to an optimal solution and takes much lesser time. But there may be case where we have to handle different objectives. So in that case, A star not perform that well in those scenarios, especially in dynamic environment. So to overcome these, we have BLP, bi-level programming. In BLP, we can basically assign different objectives in different levels, but it suffers from higher computational time. Similarly, greedy heuristic approach also suffer from high computational time, but these are easy and simple to implement. And also, like, we may not able to reach sometimes the optimal solution with greedy heuristic approach. So this is basically gives the popularity of different heuristic approaches for UAV path planning. So as we already discussed, the A star is most popular algorithm of all, followed by BLP and GH. So to conclude this video, I'm going to say that like UAVs are day by day becoming integral part of the society, and taking place and used in several different applications such as delivery services and military and all. So UAV path planning has become an important research issue, which has attracted many researchers and academicians to uh, take part in the research in the field of aerial robotics and automations. So in this video we have so far discussed UAV path planning and its optimization, different optimization criterias and constraint, and also we have discussed several heuristic based approaches, their benefits and flaws. So that's all for the video. These are the references. Thank you. So if you like this video, and like if you get something informative about the video from the video, so please do like and subscribe the channel. In case of any query, please write down comment. We will try our best to reply to that. Thank you everyone.